In this problem, we want to find y prime using implicit differentiation for this equation, 2x squared plus e to the 2xy equals 9. So it's implied here that y is a function of x, or y depends on x, okay? So when we use implicit differentiation and we take the derivative of both entire sides of the equation, we're assuming y is a function of x. So first we're going to take the derivative of the left, so the derivative of 2x squared plus e to the 2xy equals the derivative of 9. So on the left, the derivative of 2x squared is 4x, and the derivative of e to the 2xy. For that, we have e to a function, so applying the chain rule, we get e to itself, to the inside function, times the derivative of that inside function, so the derivative of 2xy, which I will figure out in just a moment, and that is equal to 0, although I'm going to rewrite that. So it's e to the 2xy times, I'm going to switch colors here, times the derivative of 2xy equals 0. Okay, so now we need to find the derivative of 2xy, and that's a rather long derivative. Actually, I need more space. Let's start over here. So that's why I just wrote derivative of 2xy, and I'm going to figure it out now. Okay, so for that, we have 2 times x times y. So we're going to have to use the product rule. Okay, for the product rule, I'm going to group together the 2 and the x as to be my first factor, and the y will be my second factor. All right, we're multiplying two variables, so we're going to use the product rule. So the product rule says it's the first factor, which is 2x, times the derivative of the second factor, the derivative of y is dy dx, plus the second factor is y, times the derivative of 2x is just 2. All right, so the derivative of y is dy dx because y is a function of x. But for the derivative of x, that's just 1 because x is the independent variable. Okay, so now we have fully taken the derivative, so now we can solve for y prime or dy dx, same thing. So let's see, I'm going to distribute this out, although you don't necessarily have to. I think it would be easier to solve if I just distribute that over those parentheses. So we'll have 4x plus e to the 2xy times 2x times dy dx. So I'm going to reorder a little bit and put 2x times e to the 2xy times dy dx plus y times 2, let's write that as 2y, times e to the 2xy. Now I want to get the derivative by itself, so I'm going to subtract this 4x and this term over to the right. So on the left I'll have this 2x e to the 2xy times dy dx equals negative 4x minus 2y times e to the 2xy. So to solve for dy dx, we can divide both sides by its coefficient, this whole factor there. So dy dx is equal to the right side, negative 4x minus 2y e to the 2xy, all divided by 2x e to the 2xy. So that's how you would find that derivative using implicit differentiation, taking the derivative of both sides.